Vivo X80 Pro, Snapdragon, camera test. Peace be upon you, my dear friends and followers of the channel. How are you today? I hope you are well and in good health. Today with you is a beautiful, new and important video for everyone. This video will be called the Vivo X80 Pro, Snapdragon, camera test. But before watching the video, subscribe to the channel and like and share so that it reaches the largest number of people. Now let's watch the video and I hope you like it. We put the Vivo X80 Pro, Snapdragon, through rigorous benchmark camera tests to measure its performance in photo and video quality and zoom from an end-user perspective. I will explain the device's performance in a variety of tests and several common use cases and aim to highlight the most important results of our tests through a snippet of the data captured. Overview. Main camera specifications. Primary camera, 50 megapixel sensor, f/1.57 lens. Ultra wide camera, 48 MP sensor, f/2.2 lens. 2x telephoto camera, 12 MP sensor, f/1.85 lens. 5x telephoto camera, 8 MP sensor, f/3.4 lens. Pros: wide dynamic range in most scenes, good texture in low light portraits, good face exposure, even in high contrast night scenes, accurate and stable video exposure, stable video colors, fast and accurate autofocus for video cons, shadows and halos appear in difficult, high contrast scenes, unstable exposure and low light and indoors, occasional loss of detail in bright light and indoor portraits, brightness, noise in all video lighting conditions, light clippings in high contrast video scenes. In our tests, the Vivo X80 Pro delivered good camera performance overall, securing it a place in the upper regions of the benchmark camera ranking. When shooting still images, the device's main strengths were good color rendition and accurate facial exposure, as well as a good balance between texture and noise even in low light. Vivo also did well at zoom, with nice colors on the ultra-wide angle camera and decent detail when zoomed into the distance. Videos showed stable exposure and color, as well as fast and accurate autofocus performance. About benchmark camera tests. Benchmark camera evaluations are conducted in laboratories and in real-world situations using a variety of subjects. The results are based on objective tests, in which results are calculated directly by measurement software on our laboratory setup, and on perceptual tests, where a sophisticated set of metrics allows a team of image experts to compare aspects of image quality that require human judgment. The smartphone testing involves a team of engineers and technicians for about a week. Image, zoom and video quality are scored separately and then combined into an overall score for comparison between cameras in different devices. For more information about the benchmark camera protocol in portrait mode, the Vivo produced accurate face exposure when taking portrait photos in most lighting conditions, even at night, but testers also found the exposure to be occasionally unstable on backlit objects. The camera provided nice texture in low light portrait photos and was able to capture nice contrast. On the downside, we saw halo effects and ghosting in high contrast scenes and an occasional loss of detail in bright light and indoor portrait photos. Exposure and color are the main features of technically good photos. For exposure, the main characteristic that is evaluated is the brightness of the main subject through different use cases such as landscapes, portraits or still life. Other factors that are evaluated are contrast and dynamic range. For example, ability to provide visible detail in both bright and dark areas of the image. Repeatability is also important because it demonstrates the camera's ability to provide the same view when taking multiple photos of the same scene. For color, the image quality attributes analyzed are skin tone rendering, white balance, color shading, and repeatability. For color rendering and skin tone, we penalize unnatural colors but respect the manufacturer's choice of color signature. Autofocus tests focus on focus accuracy, focus repeatability, shooting time delay, and depth of field. Shooting delay is the difference between the time the user presses the capture button and the time the photo is actually captured. This includes focusing speed and the device's ability to capture images at the right time, which is called no shutter lag capability. Even if a shallow depth of field can be pleasing for a portrait of a single subject or a close-up shot, it can also be problematic in some specific circumstances such as group photos. Both positions are tested. Focus accuracy is also evaluated in all real-life images captured. from infinity to close-up subjects and in low light to outdoor conditions. Texture tests analyze the level of detail and texture of objects in images captured in the laboratory as well as in real-life scenarios. For landscape shots, special attention is paid to the level of detail in the bright and dark areas of the image. Objective measurements are performed on chart images captured under different illumination conditions from 1 to 1000 lux and different types of dynamic range conditions. The charts used are Xmark, DMC, chart and dead leaves chart. Noise tests analyze different noise attributes such as intensity, color, granularity, and structure in real-world images as well as chart images captured in the laboratory. For natural images, special attention is paid to noise on faces and landscapes, but also on dark areas and high dynamic range conditions. Noise on moving objects in natural images is also evaluated. Objective measurements are made on chart images captured at different conditions from 1 to 1000 lux and different types of dynamic range conditions. The scheme used is the dead leaf chart and a standardized measurement such as visible noise derived from ISO 15739. The effects assessment looks at lens vignetting, chromatic aberrations, geometric distortions, edge ringing, halos, ghosting, quantum, and unexpected hue shifts, among other types of possible unnatural effects on images. The more severe and more frequent the effects are, the greater the points deduction on the score. The main effects observed and corresponding loss of points are listed below. Preview tests analyze image quality in the camera app's preview of an image, paying special attention to the difference between capture and preview, especially regarding dynamic range and bokeh effect application. Smoothness of exposure, color and focus adjustment are also evaluated when zoomed from the minimum to maximum available zoom factor. Preview frame rate is measured using the global LED timer. About Xmark camera zoom tests. Xmark engineers capture and evaluate more than 400 test images in controlled laboratory environments and in outdoor, indoor and low-light landscape scenes, using default camera settings and dial zooming at various zoom factors from ultra-wide to ultra-long range zooms. Evaluation is performed by visual inspection of images against a reference of natural scenes, and by making objective measurements of histogram images taken in the laboratory under varying conditions from 20 to 1000 lux and color temperatures from 2300 K to 6500 K. The Vivo X80 Pro delivered decent performance when zooming in or out from the primary camera. The ultra-wide camera captured beautiful colors. When zoomed in with the telephoto camera, the images showed good texture and accurate exposure. These tests analyze the ultra-wide camera's performance at several focal lengths from 12mm to 20mm. All image quality attributes are evaluated, with special attention paid to such artifacts as chromatic aberrations, lens smoothness, and distortion. The images below are an excerpt of the scenes tested. About Xmark camera video tests. Xmark engineers capture and evaluate over 2.5 hours of video in controlled laboratory environments and in low light, indoor and outdoor landscape scenes, using default camera settings. The evaluation consists of visually examining naturalistic videos captured in various conditions and running objective measurements on videos of histograms recorded in the laboratory under various conditions from 1 to 1000 plus lux and color temperatures from 2300 K to 6500 K. In our tests, exposure and colors were stable across all conditions in videos captured by the Vivo X80 Pro. Additionally, autofocus was fast and accurate in video mode. However, some brightness noise was visible in all conditions and we noticed some distortion in high contrast scenes. Exposure tests evaluate the brightness of the main subject and dynamic range, that is the ability to render visible detail in both bright and dark areas of the image. Exposure stability and temporal adaptation are also analyzed. Image quality analysis looks at color rendition, skin tone rendition, white balance, color shading, white balance stability and its adaptation when light changes. Texture tests analyze the level of detail and texture in real-life videos as well as videos of textures recorded in the lab. Natural video recordings are evaluated visually, with special attention paid to the level of detail in bright areas as well as in the dark. Objective measurements are made of chart images taken at various conditions from 1 to 1000 lux. The charts used are Xmark, DMC, Chart and dead leaves chart. Noise tests analyze different noise attributes such as density, color, granularity, structure and temporal aspects on real-world video recordings as well as videos of diagrams captured in the laboratory. Natural videos are evaluated visually, with special attention paid to noise in dark areas and high dynamic range conditions. Objective measurements are made on chart videos recorded at various conditions from 1 to 1000 lux. The scheme used is the Xmark Visual Noise Chart. The stabilization rating tests the device's ability to stabilize shots thanks to software or hardware technologies such as OIS, eyes, or other means. The evaluation looks at residual motion, smoothness, gel artifacts, and residual motion blur in walking and running use cases in different lighting conditions. The video below is an excerpt of one of the scenes tested. Artifacts are evaluated using MTF and ringing measurements on an SFR chart in the lab as well as frame rate measurements using an LED universal timer. Natural videos are evaluated visually by paying special attention to artifacts such as aliasing, quantization, occlusion, and color shift, among others. The more severe and more frequent the artifacts are, the more points are deducted from the score. At the end of the video, I thank you for watching and I hope you liked it, and see you in a new video.